Ladies and gents, sorry for the brief technological delay. We're with you now. Thank you all for joining us, both online and in the room. It's my great pleasure today to introduce a PhD student, our own PhD student here, Mabatho Mapiloko, who's joining us today to talk about her evolving PhD research. Mabatho did her undergrad and her MSc at the University of Free State, and a subsequent undergrad and honors at the University of Free State, and then an MSc here, the coursework and research report here in economic geology, and now she's doing a PhD with Marina Yudovskaya and Professor Paul Nex. So thank you so much for joining us, and over to you. Good to go.
Hi, everyone. My name is Mabatho Mapiloko, and today I will be presenting to you my MSc results combined with the work that I'm currently doing for my PhD research. So the general aims for my study are to establish the magnetic stratigraphy of the Uitloop farm and to correlate these units with the correlate these units and their mineralization with those of the better understood Has Valley and Twerp areas, and to constrain the sources of chemically primitive chromatiferous lower zone and PLATREEF magmas and their role in the sequestration and fractionation of chalcophore elements for the critical zone magmas. Some of these objectives I have already were part of my MSc, and then some I'm currently working on, so the data is not quite complete, but I will paint a picture. So the stratigraphy of the Rustenburg layered suit in the northern limb is quite different from the rest of the Bushveld complex. One of the main differences being that the lower zone sequences here are emplaced as channelith-like bodies that intruded through the Transvaal metasedimentary rocks, as well as yeah, it's okay. It's different, but okay. Sorry. And this project is mainly based on the Uitloop farm, which hosts the lower zone intrusion, which is exposed as two separate bodies, which are the Uitloop 1 and the Uitloop 2 sub-bodies. Sorry, please hang on. Sorry, I think, okay. Yes. Okay, no, it's okay.
You're good.
Yes, I'm
okay.
Sorry, guys. So according to the work that was done by Van der Merwe in 1978, which was the last time these bodies were sort of worked on in detail, Van der Merwe stated that these sub-bodies are composed of serpentinized peridotites as well as noritic rocks. Although the true thickness of these bodies is currently uncertain, we're not as sure yet because the area has not been studied extensively. Historical boreholes suggest that these two bodies have thicknesses that range between 800 meters and about 1,300 meters. The Uitloop 2 sub-body is underlain by the calcareous metasediments of the Tunisford group, and while the Uitloop 1 is underlain by Archean granitoids and overlain by dolomites that form the hanging wall, the footwall to the Uitloop 2 sub-body. Now, this area is of interest because it is speculated that the lower zone magma and the dolomitic footwall rocks may have generated PLATREEF style mineralization, which is similar to the main PLATREEF body, which is just in the eastern side of the eastern periphery of the Uitloop 2 body. And then moving on to the work that was previously done by many companies dating back to the 1960s. Companies such as MinEx, Rain Mines, and Falcon Ridge, as well as Southern Era, conducted geochemical studies in this farm, and they found high copper anomalies, particularly in the southern as well as in the central part of the farm. And these results also showed high nickel anomalies in the western areas. And based on this information, as well as historical boreholes, the Uitloop 2 subbody is the current exploration target for the Lesotho Platinum Uitloop's Zebediela project. Mineralization styles targeted in this area are the PLATREEF critical zone mineralization, as well as the nickel-rich semi-massive sulphide mineralization that is associated with lithologies close to and within the footwall, similar to what is seen at the Uitkomst complex, sorry. The most recent boreholes are the Z series of boreholes, which were drilled on and near the Uitloop 2 subbody between the years 2011 and 2021. The first 16 boreholes, which are Z1 to Z16, targeted nickel sulfide mineralization, while Z17 and Z18 targeted semi-massive sulfide contact style mineralization, and Z19 to Z22 targeted PLATREEF style mineralization. And the most recent boreholes, which were drilled last year, which are Z23 to Z30, were drilled all the way across the Uitloop 2 subbody. For my MSc, I mostly focused on the boreholes that were drilled specifically for PLATREEF style mineralization. Although I'm logged all 4 boreholes, I mainly used Z19 and Z20 as part of my MSc. And in this area, we confirmed, the results confirmed presence of PLATREEF style mineralization. The PLATREEF lithologies in this area consist of mainly phosphatic pyroxenites, which consist of orthopyroxenites and interstitial plagioclase, some clinopyroxene, and the phosphatic hasbogates consist of mostly olivine plagioclase and some orthopyroxenes. And both these lithologies host chromite mineralization. And moving on to other types of rock types that we observed are noritic rocks, as well as gabbronorites. The hanging wall to these lithologies consists of dolomites of the Deutschland Formation. And between the hanging wall and the PLATREEF stratigraphy, we see these hybrid rocks, which consist of mainly recrystallized clinopyroxene and orthopyroxene, as well as carbonates, which we can say they point towards, or they prove that there was assimilation between the PLATREEF as well as the Transvaal supergroup rocks. These Deutschland Formation rocks consist of the footwall. The Deutschland Formation also forms the footwall to those PLATREEF sequences, and they consist of mainly various varieties of hornfelses as well as diamectites. And these Deutschland Formation sequences are underlain by banded iron formations of the PENGE formation, as well as calc-silicates belonging to the Malmani group. We did some bulk geochemical studies and on the Uitloop, and most of these results are consistent with PLATREEF affinity, as the mafic and ultramafic rocks are enriched in magnesium content. And although most of this data wasn't really that useful, as we didn't have a lot of samples to work with, we found that the magnesium as well as the chrome content were useful, as we used them to sort of identify where in the Rustenburg layered suits, where we can sort of place the Uitloop area in the Rustenburg layered suit. And we used a theory by Seabrook, which suggests that the critical zone has chromium magnesium oxide ratios that range between 80 and 120, while the main zone has ratios that range between 40 and 60. And as you can see, majority of the mafic and ultramafic rocks from the Uitloop farm plot well over 80, which suggests that these rocks are actually of critical zone affinity. The PGE mineralization in these boreholes is mainly associated with feldspatic pyroxenite as well as feldspatic hasbogites and hybrid rocks towards the footwall contact. And we identified two styles of mineralization, which are the contact style PGE mineralization as seen in borehole Z19, as well as reef style stratobound mineralization as we see here in borehole Z20. Now, these feldspatic pyroxenites, as I mentioned earlier, that the feldspatic pyroxenite and feldspatic hasbogites of the PLATREEF host chromite mineralization. We looked at these chromites and we realized that most of them are hosted by pyroxenes, olivines, as well as interstitial plagioclase, and their morphologies mostly range between euhedral and anhedral. And we also noticed that there's also some chromite remnants that are a result of replacement by phlogopite. We did some microprobe work to determine the composition of these Uitloop chromites in different rock types. And we noticed that the Uitloop chromites are closely match the PLATREEF's chromite compositions, as they have a wide range of compositions, which can be attributed to magma contamination. We also used olivine chemistry to help distinguish between the lower zone and the PLATREEF. We didn't have much data to work with, as most of the olivine bearing rocks in this area are very serpentinized, but we did have one sample from borehole Z20, which had relatively fresh olivines. And these olivines have a high nickel content as well as high magnesium content. However, the magnesium content in these olivines are not as high, as we rule out the fact that these chromites might be of lower zone because of the magnesium content is not as high as we would normally expect the lower zone olivines to have. And also the presence of interstitial plagioclase in the host rocks also point towards PLATREEF type of rock types. We observed exsolution lamellae, as you can see in that second diagram. These exsolution lamellae consist of clinopyroxene and chromite, and we normally see these exsolution lamellae in lower zone olivines, but because we didn't have much data to work with, we just decided that most of the data indicated that we are still in the PLATREEF stratigraphy. Moving on to discussions, the bulk geochemistry and olivine chemistry. The bulk geochemistry and olivine as well as chromite chemistry of the studied Uitloop offshoot are consistent with the PLATREEF affinity. And the mafic and ultramafic lithologies, as we saw, have chromium magnesium oxide ratios, which are typical of critical zone, which is above 80. And the Uitloop sulphide enriched silicate rocks are characterized by high contaminated signature, which is expressed as an enrichment in incompatible trace elements. These Uitloop PLATREEF offshoot rock types also have high nickel and copper concentrations, specifically at the base, which is likely a result of the extraction into immiscible sulfides from magma that reach sulfide saturation due to assimilation of external sulfur from the footwall. The composition of chromites on Uitloop is distinguished by higher chromium numbers and lower magnesium numbers compared to the Miriski reef chromites, but they show diverse compositions which are typical of PLATREEF chromite compositions. Moving on to the conclusions that I reached as part of my MSc, we suggested that the magmatic sequences in this area are a previously unrecognized extension of the PLATREEF offshoots. And this PLATREEF offshoot may have formed by multiple injections or via coalescence of several cells of critical zone or PLATREEF type and placed into the Transvaal metasedimentary succession. The irregular intercalation of mafic and ultramafic lithologies in the Uitloop area could provincially be explained by out-of-sequence cell-like emplacement, and this still requires further investigation. Now that we have established the characteristics of the PLATREEF in the Uitloop area, our next step was to use this information to distinguish between the lower zone and the PLATREEF sequences. Recent boreholes that were drilled across the Uitloop 2 body also intercepted PLATREEF beneath the lower zone sequences, as we can see there in Z28. And the lower zone sequences here consist of hasbogite and also pyroxenites, while the PLATREEF sequences here in the southern end of the Uitloop 2 body consist of feldspatic pyroxenite and feldspatic hasbogite. And then as we move towards the center of the Uitloop 2 subbody, we see that the lower zone sequences here also consist of hasbogites as well as serpentinites, which are a product of alteration of danites. And the PLATREEF sequences here also consist of feldspatic hasbogite as well as feldspatic pyroxenite and noritic rocks. And we see that these rocks, similar to what we saw just southeast of the Uitloop 2 body, also host well-defined chromatite seams, which I will discuss later in the presentation. And then towards the north, we again see these lower zone sequences, which consist of hasbogite and pyroxenite, as well as highly serpentinized danites. And the PLATREEF here as well consists of noritic rocks, as well as feldspatic pyroxenite. The footwall to these lithologies on the Uitloop, to the PLATREEF as well as the lower zone sequences in the study area consists of hornfelses as well as diametites of the Deutschland formation, which are underlain by the PENGE formation, as well as dolomites of the Malmani group. We did some geochemical work and we plotted our results, which are in orange, against the XRF Horok chemistry that were provided to us by Umbono, which is the company that is currently running this project. And we see that the PLATREEF as well as the lower zone sequences here are highly enriched in nickel as well as chromium. Although we noticed that there's also chromite mineralization in the PLATREEF beneath the lower zone sequences on Uitloop 2 body, we have not done any chemistry. However, the morphology also, the chromite morphology resembles what we saw earlier in the just southeast of the Uitloop 2 body. And then sulphide, the magmatic lithologies on the Uitloop farm are highly inundated with sulphide mineralization. And in both the PLATREEF as well as the lower zone, we observe a general trend of increase in sulphide mineralization from the top, where we have finely disseminated and blebby sulphides, which transition into more net textured and massive sulphides towards the base. And the most abundant sulphides in this area are pyrrhotite, pentlandite, as well as chalcopyrite. We also notice some secondary sulfide minerals such as pyrite, as well as millerite, violarite, which is a result of alteration of pentlandite. There is evidence of sulfide fractionation in both the PLATREEF as well as the lower zone sequences, as we observed some primary sulfide textures, which are indicated by where we see sulfide blebs, which consist of mainly pyrrhotite with exsolved and granular pentlandite, as well as some droplets where pyrrhotite forms sort of the core of the bleb, and pyrrhotite and chalcopyrite are more confined to the rims of the pyrrhotite grain. And these rocks are also, these sulfides are also associated with some platinum group mineralization. Sulfide mineralization, we also observe massive sulfides in the footwall rocks, where we also observe these primary textures where pyrrhotite forms the rim with pentlandite and chalcopyrite confined towards the edge of the pyrrhotite grains. And the footwall lithologies are also, as I said earlier, are highly undated with sulfide mineralization. And these sulfides in the Deutschland diamectite are associated with the angular fragments in diamectite. And in the PENGE formation, the sulfides are orientated along the bedding structures where they are associated with the magnetite bends. And the Malmani group, which is more adjacent to the PENGE contact, is also highly enriched in sulfides. But as we go deeper, the Malmani group lacks sulfide mineralization. So we did some multiple isotope study we did some multiple sulfur isotopes on 10 boreholes, and this image here shows where we selected samples to sort of represent the sulfide mineralization in the lower zone, in the PLATREEF, as well as in the footwall lithologies. The source of sulfur required for the process of sulfide saturation is responsible for the development of nickel-copper PGE mineralization in the Uitloop area is uncertain. So the multiple sulfur isotope study helps to investigate the origin of the sulfur, which aided in the formation of this mineralization. So essentially, this technique allows us to not only trace the magma counter rock interaction, which helps determine whether the sulfur that aided in the sulfide saturation in the Uitloop area is of magmatic origin or from footwall rocks. So these are the results that we found, and multiple sulfur isotope compositions not only help establish the sources of sulfur required for sulfur saturation, but also helps determine the timing of the additional sulfur which was added from the footwall rocks. And anomalous sulfur 33 values are indicative of Archean counter rock sulfur sources, whereas pristine PLATREEF magma rocks will show near zero sulfur 33 values, while the sulfur 34 for pristine PLATREEF magmatic rocks normally range between -2 as well as +2. We identified potential Archean sulfur and members that suggest that the samples in the region are indicative of mixing between Archean and Proterozoic sulfur and members. The Uitloop lower zone and the PLATREEF rocks show a wide range of sulfur 34 and non-zero sulfur 33 values. And this means that the sulfur isotopic compositions of the PLATREEF and lower zone sequences are indicative of the incorporation of Archean sulfides, Archean sulfides derived material into the magma, which suggests magma country rock interactions in the magmatic chamber. This is all I have prepared for you today, but obviously this is still an ongoing study. Thank you.
Thank you, Mabatho. That was fantastic. Super interesting. Do we have any questions from the floor or from the audience on Zoom? One lovely comment. Okay, do we have any questions? Question right at the back. I think maybe you should just come up to the microphone so the Zoom audience can hear you as well. Sorry.
So I wanted to ask about the mineralization between the Uitloop and the Nkomati. Are there any similarities between the two? You can't hear me.
Speak loudly, everyone must hear you.
Yes. So the Uitkomst, I'm asking about the Uitkomst Nkomati region and the Uitloop. Are there any similarities that you found between both? And is there more pentlandite mineralization in the Uitloop compared to the Nkomati? Okay. So there isn't really, there's more pyrrhotite than pentlandite, but also in the Uitloop region, we see, yes, it's true, we see some massive sulfur veins in the footwall rocks. In the footwall rocks as well as in the magmatic packages that are close to the footwall rocks, but they're not as extensive as at Uitkomst.
Good question, thank you. Can I just follow, I'll come to your question now. Can I just follow up and ask, do you think that this body is similar in its intrusion style to Uitkomst? Is it a similar kind of satellite body to the PLATREEF?
Yes.
Okay, it's a satellite body. Sarah, yeah, I think it's easy if you come here, and then we'll go to Sue.
Okay, then I just had a quick question about your multiple sulfur isotopes. Were they bulk rock isotopes or in situ? What kind of standards did you use and what method did you use?
Thank you. Okay. I see I might as well couple it with this question here. So the analysis was done by my supervisor kindly in Russia, and I recently just got these results. So next time I'll have a better answer for you, but they're in situ.
Okay, Sue, would you like, you can come up so long, but Sue, go for it.
Hi, Grant. Hi, great talk. You have a wonderful voice, as the was noted in the comments. I just wanted to ask, has any geophysics been done or is any planned, and just to help map out things more continuously? Thanks.
Yes, geophysics was done back in 2018, but I was present for the investigations, but I'm not a geophysicist, and they never shared the data with me. So yeah. But
Do you know what kind of data were collected?
As I said, I'm not a geophysicist, but
Okay, fantastic. It might be something to follow up for at the PhD level. Yeah.
Okay, we have another question here. Introduce yourself.
Okay, hi everyone. My name is Nomtlatla, and my question is, since this place is very similar to the PLATREEF, why is it that the PLATREEF has more disseminated sulphide bodies, and then this one has more massive? Actually, it ranges from disseminated to massive going down.
First of all, as we know, the main PLATREEF body, but actually the main difference between the PLATREEF on Uitloop is that the PLATREEF is mainly defined by the fact that it is overlain by the main zone. But in this area, it's offshoots, and they are intruded within the Transvaal metasedimentary rocks. And as you go further north in the Uitloop 2, as we saw, they're intruded within they're sort of intercalated with lower zone sequences. As for the sulphide mineralization, it's similar. They're disseminated as seen in the main PLATREEF body, and there's still those blebby and net textures, but the massive sulphides are mostly towards the footwall. It's not within the actual PLATREEF.
Okay, any other questions? Yes.
I have a more lighter question. Hi, thank you very much for the cover. Beautiful. I have a more lighter question. I'm an undergrad student, so I'm asking myself, what inspired you to like choose this particular topic for your master's? Yeah. Yes, and also another one is on the PLATREEF, like the area you chose, like the ore grade and all of that. Can you mine it?
Okay, as to how I ended up working on the PLATREEF, this project was first introduced to me by Professor Christoph Gowet when I was still at UFS. Another student we were actually working on the lower zone intrusions. One of my colleagues was working in the lower zone intrusions further north, like the Bultfontein, and I was in the Uitloop and Has Valley. And then when I was looking for projects to work on for my MSc, this company which owns rights to that particular area went to the UFS to look for a student who could work on that project. So I was that person, but they asked me to come to Wits instead, so I came to Wits.
Yeah.
One of the other questions.
This is going to be a feasible deposit.
Oh, yeah. It is, because we're revisiting it. It was studied way back in the 1960s, 1970s. So now we're working on this project again. So.
Okay, Mabatho, thank you so much.
Thank you.